In this video, I'm going to be going over the divergence and curl of a vector function. So recall that del is a vector consisting of the partial derivatives of each of its components with respect to it. So the divergence of a function is just the divergence of a vector field is just del and then the dot product of that vector field. And the curl of a vector field is just the del function, the del vector crossed with the vector field. So let's use as an example let's think of something easy. So I'll just say this is y plus 2x, z plus x, and y squared plus z squared. So this is our vector field. So the curl, let's start with the divergence of this vector field. All right, so divergence is that dotted with f. So that's going to give us the derivative with respect to x of y plus 2x plus derivative with respect to y, z plus x, plus the derivative with respect to z of y squared plus z squared. So this is going to give us 2 plus 0 plus 2z. So the divergence of this function would be 2z plus 2. Right? So this is going to be a scalar, right? Because your dot product, you're taking the dot product of two functions. So the divergence is a scalar. And then if you notice, the curl is going to end up being a vector. So this doesn't have directions, it just has a value. This doesn't have, this has both a direction and a value in a magnitude. So if we take the curl of this, we are going to end up with, so we have the curl so that's going to be partial x, partial y, partial z. And then we have y plus 2x, z plus x, y squared plus z squared. I usually like to put this in a matrix. The way I like to do the cross products is I put it in a matrix and just take the determinant of it. So what I do is, you can do this anyway you know how to do a cross product, but the way I do it is I say this is I hat, j hat, k hat, and then I say the first line is going to be partial x, partial y, partial z, and then the next line is going to be y plus 2x, z plus x, and y squared plus z squared. And then I just take the determinant of that. So we end up with I hat times the derivative with respect to y of y squared plus z squared minus the derivative with respect to z of z plus x. Then we have minus j hat. Right, so we take this and we go, and in this case, instead of multiplying, you're taking the derivative of it. So you do this and that. You do this minus that, I hat. Then we do minus j hat of this minus that. So we have partial x of y squared plus z squared minus partial z of y plus 2x. And then we go plus k hat. Partial x of z plus x minus partial y y plus 2x. And so that is going to give us, this value ends up being 2y minus 1 I hat, right? So this is 2y, this is 1, minus, this is 0, because there's no x's in here, and that's 0, so minus 0 j hat, that's a messed up j. And so this ends up being 1 minus 1 k hat. So this is going to give us 2y minus 1 I hat. That's 0, that's 0. And so your curl of this vector field is going to end up being 2y minus 1, 0, 0. Right, because we only have an I hat. I'm just going to go through an example using this vector field. So this vector field is one that just points radially out from the origin, depending on where you're at, of a unit of 1, right? Because this is the magnitude of x, y, z. This is just x, y, z. So it's just going to point out from the origin. So let's find the divergence and curl of this field. So we have del dot f. So that is going to be the partial derivative of this. Plus the partial derivative of what this too, right? So we do this plus that, x squared plus y squared plus c squared, and plus the partial derivative of the z component. So I ran out of space, so I'm just going to put an arrow there. So the partial derivative with respect to x would give me, I'm going to rewrite this as x times x squared plus y squared plus z squared to the 1/2, to the negative 1/2, just so I can do the derivative easier. This is going to give me x squared, right? So we're taking the derivative of this, and that's going to give me x squared plus y squared plus c squared, negative 1/2, plus x times negative 1/2, x squared plus y squared plus z squared to the negative 3/2 times the derivative of the inside is 2x. So that's going to give me x squared plus y squared plus z squared to the negative 1/2 plus 1/2 times 2 is just 1, so that's going to give a negative x squared times x squared plus y squared plus z squared. And if you notice, this derivative is going to be the same thing, except instead of x we have y, and the same thing over here, instead of x we have z. Right, because we're taking the derivative of x with respect to with respect to x, y, z. They're going to be symmetric. So this is going to give us 3 of these, right? Because this is all going to be the same. So 3 times x squared plus y squared plus z squared to the negative 1/2 minus, we're going to have 1x squared from the x component. We're going to have, yeah, this should be a negative 3/2. Sorry. So when we do the derivative of the x component, we're going to get this minus x squared times this. When we do the y component, we're going to get this minus y squared times this. And when we do the z component, we're going to get this minus z squared times that, right? So we're going to have 3 of these, and then we're going to have a x squared, y squared, z squared times x squared plus y squared plus z squared. Because I'm just adding up x squared times this minus y squared times this minus z squared times this. And then, of course, this is a 1, right, because it's just the power of 1. This is the same as that, so I can say 1 minus 3/2 is going to give me 3 x squared plus y squared plus z squared to the negative 1/2 minus x squared plus y squared plus z squared. 1 minus 3/2 is going to be minus 1/2. So we have 3 of these minus 1 of these. So that's going to give us 2 of them. Which, of course, can be rewritten as this. So that's the divergence of that function. Now I'm going to go over finding the curl. So our f as a function of x, y, and z is 1 over the square root of x squared plus y squared plus c squared x, y, z. This is just a different way of writing what I wrote earlier. So we have del cross f. So I'm going to say I hat, j hat, k hat, partial x, partial y, partial z. Then I'm going to say x over just for the purposes of saving writing, I'm going to say that R is this. Just because I don't want to write this whole mess out each time. So this is X over R, Y over R, Z over R. And so the curl is going to be I hat times partial Y, Z over R, minus partial, right, because this minus that, so partial Z of Y over R, minus, so we've got this minus that, so partial X, Z over R, minus partial Z, X over R, I j hat, plus, move on to k hat, we get partial X of Z over R, that minus that, so minus partial Z X over R, k hat. So we're going to have the derivative of this with respect to y. So y is in R. So let's find the derivative of 1 over R with respect to y. Because if we find it with respect to y, it's going to be the same with respect to z and x. So you have x squared plus y squared plus c squared to the negative 1/2. So I'm going to pull out the negative 1/2. X squared plus y squared plus c squared, negative 3/2 times 2y. So that is always going to be the derivative with respect to y. If it's with respect to x, this will just be an x. If it's with respect to z, this will just be a z. Because x, y, and z are interchangeable in this case because it's symmetric. So partial x is going to be z, and this ends up being negative just this, x squared plus y squared plus c squared, negative 3/2. So this is going to be z, and then I can say that this is going to be 1 over negative 1. Yeah, I'll just write it out. So this is going to be z times negative x squared plus y squared plus z squared, negative 3/2, minus x times negative this, and so that is our I hat. We have our j hat, which is going to be negative, oh, sorry, we still have the y up here, so that means there's a, oh, there's a y here, and there is a z here. And so this is going to be z negative x squared plus y squared plus c squared negative 3 over 2 times x minus x times negative x squared plus y squared plus c squared negative 3 over 2 times z. Yeah. And so then we have the k hat. So this gives us this. Right? So this can be simplified as the vector where we have, so each one of these terms have this term in it. So I'm going to pull that out. So I'm going to pull out x squared plus y squared plus c squared negative 3 over 2. Yeah, and there's a negative, so I'm just going to pull the negative out too. And that leaves us with the vector zy minus xz negative zx minus, so negative minus is a plus, xz This should be a y, sorry, right? Because this is our z, this is the y that comes out of the derivative, and this is the y that started the whole thing out, and this is the z that came out of the derivative. So we get zy minus yz, and then we get negative zx plus xz, and then z, yep, negative, oh, I pulled the negative out from these negatives out. So we get negative, we get zx minus xz. And so that gives us negative x squared plus y squared plus c squared negative 3 over 2. This is 0, this is 0, this is 0, and that's the same thing as just saying 0. Right, so this ends up being the 0 vector. So the curl of this function is 0. So I'm going to go through one more example. This is an example where the x component only depends on x, the y component is a function of y, and the z component is a function of z. So the divergence of this is going to be the derivative of this with respect to x. So you're going to have df of x dx plus dg of y dy plus dh of z dz. Right, and those are just going to be the derivatives of these because there's only a x and a y and a z in the function. If you take the curl you are going to end up with I, J, K, partial x, partial y, partial z, f of x, g of y, h of z. You're finding the determinant of that. So the I component, the derivative of h with respect to y is 0, because there's no y's in it. The derivative of g with respect to z is 0. And if you notice, since, so we have x paired with z, the derivative of this function with respect to x is going to be 0, because there's no x's in it. This function with respect to z is 0, because there's no z's in it. And the derivative of this with respect to x is going to be 0, because there's no x's in this. The derivative of this with respect to y is going to be 0, because there's no y's in that. So if you notice, if you have a function where each term, if you have a vector field where each component of the vector field depends only on that position of the field, your curl is going to be 0, the 0 vector. So you're going to have 0, 0, 0, which is 0.